Hi everyone, our topic for today is all about guidelines on energy conserving design of buildings. My name is Kate Guardarama and I'll be your first reporter in this topic. The guidelines of energy conserving design of buildings is not just an architectural document. It is a technical standard that connects electrical, mechanical, and structural systems to ensure the buildings operate efficiently. A building performance is not determined by one discipline alone. It requires coordination of all engineering systems. The guidelines on energy conserving design of buildings is an essential reference for understanding how buildings consume and manage energy. This book is essential because it teaches how different buildings features like walls, roofs, windows, AC systems, pumps, fans, and controls change the electrical load. Buildings use a large portion of country's electricity, and energy efficient design directly affects national energy savings. This topic will help us understand why AC systems consume so much energy and what design choices reduce that consumption. Even architectural decisions like window size affect electrical requirements such as cooling load, motor sizing, and operating current. It will explain the difference between good design versus compliant design, showing that even if a system works, it might still be wasteful or oversized. Electrical engineers must know how motors, fans, chillers, and HVAC controls affect total energy use and monthly electricity bills. So, because oversizing equipment means higher current, bigger breakers, larger cables, higher demand charges, and unnecessary operating costs. As an engineering student, studying this manual is important because it answers our major questions we will face in the real world, like how does my electrical design affect the total energy consumption of a building? So our designs directly influence the size of transformers, conductors, protection devices, and operational costs. It also answers the questions of many students that are often confusing, such as why does the size of the windows affect the size of the air conditioning system? How do U values SHGC, OTTV, and SRI relate to electrical energy consumption? Why do we need controlled ventilation and not just bigger AC units? How does pump and fan efficiency affect building power demand? So these questions show how thermal performance and mechanical efficiency translate in electrical load calculations. The guidelines also connect directly to laws such as RA 11285, which is the Energy Efficiency and Conservation Act, the Philippine Green Building Code, and the National Building Code of the Philippines. So understanding these laws is a professional responsibility for future engineers involved in design and compliance. Most importantly, the book teaches us how to design buildings that are energy efficient, environmentally responsible, and financially practical. Energy efficient design reduces monthly cost, improves comfort, and increases the lifespan of mechanical and electrical systems. So first is part one, section four, building envelope. So the building envelope is a physical barrier between indoor and outdoor environments that includes walls, roofs, doors, windows, skylights, and other components. So it controls heat, air, and moisture transfer, affecting energy efficiency and comfort. Why does the building envelope matter? So is the one that controls the amount of heat gain entering the building. It affects the humidity, comfort, and cooling load. It helps reduce electricity use by lowering air conditioning requirements. So for application, it requires for all air-conditioned spaces in new buildings or expansion with greater than or equal to 112.5 kVA load or greater than or equal to 10,000 m squared TGFA. So it ensures large buildings comply with minimum energy efficient design. Exception for naturally ventilated spaces, only roof insulation, skylight ratio, and reflectance requirements apply. So air-conditioned spaces requires stricter insulation and air tightness. Next is rational reduces cooling load by minimizing effects of solar radiation, outdoor temperature, and humidity. So good envelope design decreases heat gain and lowers energy use. The design application includes using shading devices, reducing window-to-wall ratio or WWR, selecting low SHGC glazing, using reflective coatings, adding insulation, and improving airtightness. So these strategies reduce solar and heat gain, improving building thermal performance. Next is the design documentation. So must include architectural drawings, material specs, U values as HGC, OTTV, or prescriptive calculation skylight ratio, airtightness plan, and roof SRI. So it is a compliance must be proven through measurable values. Next, the overall thermal transfer value or OTTV method. So what is its purpose? It is the one that measures heat gain through walls, windows, and roofs. So it ensures the facade and roof do not exceed 45 watt per meter squared, preventing excessive cooling demand. So next is facade. We have three types: the sample OOTV calculation of office facade, retail facade, and the weighted OOTV of entire south facade. So first is the sample OOTV calculation of office facade. Uses wall area, window area, U values, SHGC, shading factor, and solar factor. As a result, OOTV is equal to 38.6 watts per meter squared. So next is the sample OOTV calculation retail facade. Larger glasses, area with no shading or is equal to higher OTTV. So result of OTTV is equal to 87.92 watt per meter squared. Next is the weighted OTTV for entire South facade, so combined office plus retail areas. Its OTTV is equal to 45 watt per meter squared. So the area weighted coverage ensures fair evaluation and mixed facade types. Next is the roof. So OTTV for roof considers roof area, insulation, material conductivity, and temperature difference. Sample result is OTTV is equal to 9 watts meter squared per meter squared. So roof insulation significantly lowers heat transfer from solar radiation. Prescriptive method purpose a simpler alternative in place of OTTV. So instead of computing OTTV, each component like windows, walls, roofs must mix fixed limits. Next is the solar transmittance of windows. So calculates adjust SHGC based on glazing and shading factor. Result adjusted SHGC is equal to 0.631. Allowed max is 0.640. So the windows must limit solar heat gain based on WWR. Next is the minimum insulation values. Requirements: the wall U value must be less than or equal to 3.4 watt per meter squared K. The roof U values must be less than or equal to 1.4 watt per meter squared K. And like we have an example here that the wall is equal to 2.717, so it's less than 3.4, so it passed. And next is the roof. It is 0.561, so less than 1.4, so it also passed. So the lower U values is equal to better insulation, which is equal to less heat entering the building. So next is the shading devices. Horizontal and vertical shading elements reduce solar heat entering windows. Shading factor F is computed based on the depth to height ratio. A smaller F means better shading and lower window solar gain. So example, if office window is equal to F is equal to 0.74. So yeah. Next is section. So the importance of this section 4 is important for our studies because it ensures the buildings are designed to resist heat, use less energy, and provide better comfort. A strong envelope design leads to a lower electricity bills, reduced cooling demand, healthier and more comfortable living spaces, compliance with national energy regulation, long-term durability, and performance of the building. So it is extremely important because it establishes the standards for the thermal performance of the building envelope, which includes walls, roofs, windows, doors, and skylights. These components form the boundary between the indoor and outer environment. The quality of the envelope directly affects the building energy efficiency, cooling load, indoor comfort, and a long-term performance. Next is the part 2, the mechanical system, section 5, air conditioning and ventilating system. So first, introduction of mechanical system, buildings with greater than or equal 10,000 m squared TGFA must be some mid-annual electricity use, generator, fuel consumption, and LPG usage. So it ensures the continuing compliance and monitoring of mechanical energy performance. Next is the design documentation includes load calculation, system sizing, mechanical drawings, equipment schedule, and P&ID. So these are essential for permit evaluation. Next is the load calculation. So it is based on Ash ASHRAE fundamentals include solar gain heat, conduction heat gain, internal heat gain, ventilation air load, outside air load, latent and sensible heat. So it's proper cooling load computation prevents oversizing and wasted energy. Next is the system design and sizing. So equipment must be properly sized close to actual loads. Should include central monitoring controls for efficiency. So oversized system costs more and operate inefficiency. So controls optimize performance. Then the fan system design criteria for both constant and variable air volume systems. We have a maximum fan power which is 0.5 watts per meter cube per hour. And VAV fans is greater than or equal 5 kilowatt. It is a required VSD or EC motor. So it limits fan energy consumption and ensure efficient operation at part load. Next is the pumping system design criteria. We have the max velocity, which is 1.2 meter per second. Pressure drop limit is 39.2 kilopascal per 100 meter. Must allow variable flow down to 50% of design. And so it reduces the unnecessary pump power and allows efficient modulation. So exceptions, small system or number of pumps which is less than equal to 5 kilowatts, single valve system, and systems needing higher minimum flow. Next is the air distribution system. Indoor air velocity must stay 0.2 to 0.30 meter per second, so maintains comfort without drafts or stagnant air. Next is the controls. Requirements include temperature controls, zone isolation, thermostat placement, building automation system if should be greater than or equal to 300 TR. Germicidal irrigation filtration system. So controls ensure stable comfort, safety, and energy saving. UVGI and bipolar ionization improve air quality. Next is the chiller plant insulation. So insulates pipes, equipment to reduce cooling losses. So prevent energy waste and condensation. So next is air handling system insulation. So insulates the supply ducts and components. So it's the one that maintains temperature and conditioned air. Next is the air conditioning equipment. So must meet minimum efficiency standards. So ensures low operating costs. Next is the heat recovery. Uses exhaust air to recover cooling energy. So it reduces fresh air cooling load. Next is the thermal comfort and non-air conditioned buildings focuses on ventilation, shading, and lighting. So it provides the comfort without mechanical cooling. Next is the provision for natural ventilation and lighting. So it encourages the cross ventilation and daylight opening. So it is the one that reduces dependence on mechanical systems. Next is the mechanical ventilation. So it is the one that ensures the proper air supply where natural ventilation is insufficient. So it is the one that maintains indoor air quality. Next is the importance of section 4 is it is section 4. Section 5 is important because it governs how mechanical systems are designed to achieve. So it is to lower energy consumption, proper indoor air quality, effective temperature and humidity control, safe and healthy living spaces, efficient and right-sized equipment, compliance with national energy standards, So it is the one that ensures that the building's AC and ventilation system function efficiently without compromising comfort or health. So it is crucial because it ensures the mechanical system of the building, particularly air conditioning and ventilation, are designed, sized, and operated in an energy efficient, safe, and comfortable manner. So thus this section outlines the minimum technical requirements that buildings must follow to reduce energy consumption, improve indoor air quality, and maintain the proper thermal comfort. So then let's re- then the next report will be presented by the next reporter.
Part mechanic did don't focus this part important part of mechanical system. I am and I will how they work, where they are used and how they are proper. Introduction of steam and hot water station covers the energy side of steam and hot used in buildings such as in hotels, restaurants, hotels, and laundry shops. The main purpose state criteria and standards that help engineers choose the right design and equipment so that the system uses energy and reduces operating costs. Design application before a steam or hot water system can be installed in a building. Its design must be submitted to the Office of the Building Official or OBO of the local government. This ensures that the design is safe, follows standards, and meets all regulatory requirements. And mechanical equipment manual and ID or for loop calculation determine how much sign and size the different sides of it and size for mechanical provide technical layouts and diagrams for equipment schedule. List all equipment and P and ID, the flow of or water and the control. This ensure the system well designed and is under with overall energy. Consider a heat loss, follow fire and the circulating analyze and the total loss from a of equals shall be determined. This is for a chemical compared electric state ever used in hot. Letter B number one is a heat exchanger to water. Number two heat pump. They also use to have letters steam. A centralized hot water generator shall be as near possible to the steam source through piping. Letter D for the generation a boiler with an efficiency in of 85% and above. Letter A in the absence of used as direct fired hot water generator with an efficiency rating of 85% and above. Letter F used a solar water heater on the rooftop with a 3 kilowatt electric heater backup to be used during prolonged. Number one, types of solar water heat absorbers are beta A, copper, serpentine type of solar hot water heat absorber with a capacity of 300 liters and 1 liters storage turbine. Vacuum absorber type of solar hot water with a capacity of 100 and 1 liters storage. Number 2. This can be installed with a pipe feeder and a solar hot water heat absorber in multiples of either 300 liters or 1 liters. Heating capacity a centralized water tank and an equivalent electric heater backup case of prolonged rental condominium hotels and number 3. Solar energy used in water for commercial hotels, hospitals, and high-rise residential building applications. Number 4. Solar water heaters can also serve as preheating water, steam boilers, or calorifier for efficient hot water. 6. That all boilers and hot supply with any deadline that the can 6 hot water temperature. The maximum hot water can was 45 than more than at the lower sensor is better than 5 at a higher than 5 controls. First to the required controls used in hot water systems such as boilers, heaters, or circulators operate and with help and carry help and effort to use at the purpose of controls make sure that ensure control help run effect and protect our working and energy piping into piping to it and energy efficiency, both circulating and non-circulating hot water for circulating hot water continuously flow through the pipe. This is instant hot water but requires good insulation. For non-circulating hot water does not constantly move. The water stays still and only flows when double and does it how to that as from our solar energy. Every hot water net use saves energy and one example is powered from the cloud as long as certain for at 85,000 or effectively to power other Listen, the system capture is Pakistan it minimize thriller and maximize it control the hot water without sacrificing stable plant storage tanks if you use for the covered. The supply does not match the timing of the spark electrical switch 7 5 static positive the lighting is an essential component of electrical what light covered light light stereo ideas well with such as trans express loaded docks, park area and roads run and other exterior areas often covered areas for lighting guard and exercise well electrical system. Unlike the above that have special lighting requirements, in short, guidelines for proper light and out building light of planet out of Earth that represent light allow in critical control to electric and sign up to any of the other story highlight light or light other devices and allow the light even if light is air functioning luminaires for buildings with specialized fluorescent light are called the color that also help with dignity helps to head build up from an overall energy 7 for every society run cost of anxiety that the light must match the efficacy or purpose energy sent transfer provide enough and properly light, avoid glare, and maintain good light quality. Its color accuracy is very important. Lamps with a CRI or color rendered 50 can be however, its good color quality CRI 80 or higher 75 emergency lighting that is a requirement for emergency lighting tall buildings with 10 stories or more must at least one lamp able to weather survey and emergency elevators must have at least one emergency lamp with a minimum output of 500 lumens. These emergency lights must be powered by a separate circuit with gears or uninterrupted power system of the building. This should turn on automatically during power failure and must get done on a regular basis. Tall buildings must have reliable backup drive to ensure safety during its color backup room. Big power lighting night color help the room brighter. You can start with abstract light and even lighting control. Lighting allows an adjustment repeat the colors. Each room must have at least one room vertical light. Lighting be monitored by at least 50% approved, like electronic lights, lights that are needed for emergency or that is turned off. Light is powered and still or light powered the amount of power used by light is first or of a building type of building at a maximum allowed efficient light that are adapt the total building power yield 1 divided by its for L that average power density per area type or speed is 1. Total design lighting wattage of a particular building area type total or area of a particular building area speed. Surface source automatic turn light on all activity for people count such as storage, private storage room, common file stairway, stairways, and other similar areas. Hospitals and malls lighting on parking areas must have at least 60% lighting controlled by exterior lighting outside are not necessary process or the light and on one side of the lighting 7-Eleven, hotel or case each hotel or motel must have a master certificate in this it control all the lighting. It can automatically turn the lights on or off in search or healthy energy. Rooms that require lighting for emergency constant light bulb and balance lighting for and post visual light must have separate each day lighting circuit. It's light and light and the light of light of the tall model. This lighting has by a flammable fiber seven per control of its own lighting or stars have told her that there is storage problem like switches and shelves and carry which for that light must also be versatile area and allow the lighting to form or manage. Number one, large as one is example open plan malls and parking or where areas like of individual. Number two, manual or automatic control device. Using sensors or dictators can count as control point even if manual. Number three, automatic systems that turn lights off. Number four, programmable controls. Timers or smart lighting operate. Number five, controls for properly trained operators. Lighting can be controlled from a thermal by the number controls for sleep hazards, emergency or sleep lighting stem from repair controls. Time the requirement for applying a building permit maintenance and submit to determine whether the design of the building client features on energy starting time of building. The building calculations can require the submission and occupation the following building time from the complete building time transfer. There is architectural design, first of floor plan, building elevation and site calculation open that and first have been entirely by physical data of plans. Reflective plan, interior design, number interior design, floor plan. Number nine, interior light plan and for mechanical design of air and with number for building site lighting, three electrical design, most exterior design for exterior design For hotels, don't tell common right active master or others are contract price or lighting product digital. Number 5, lighting control diagram. Number 6, sensors, time of coverage. Number 7, digital part test of the virus source controller. Number 8, science circuit drawing, calculation and test construction documents are the required for adaptation action and for higher motor trade. This is motor that's of the required to stand to it. Number 10, motors in its hat gold or number room height or rising height of electric motor must be careful. Motor that traffic is required as a height of lower level just saves energy when not running the motor at full speed. The motor high but high high or higher. first electrical that use motors, air conditioning, or electricity energy as are energy as energy SF or call it sniper values must meet the minimum requirements by the DOE and those the guidelines. Cooling systems must be energy by soap starter promoters are devices that help motors not Fahrenheit for motors 5 kilowatt stations. Soap starters are avoid sudden change equipment like high efficiency I or guitar, wine with salt, some are correctly open near their best efficiency point or BP. This is where pumps work the most. For proper pump size must keep efficiency between 80% 100% of use correct action and discharge pipe dimension. Why this is important? Because it prevents
Good day, everyone. My report covers Section 8.7 up to Section 10 of the Guidelines on Energy Conserving Design of Buildings 2020 edition. My report focuses on overhead water tank provisions, electric motor system, power distribution, and the required construction documentation for compliance. So, 8.7 overhead water tank provisions. It describes that buildings with 10 stories or more provides overhead or elevated water tanks, and the tank capacity must be at least 120% of the building's average daily water demand. This ensures continuous water supply, reduces pump energy consumption, and provides overall system efficiency. Buildings with less than 10 stories are exempt from these requirements. Section 8.8 Escalators and Moving Walkways. Escalators and moving walkways must be designed to reduce energy use when in not operation. After 1.5 minutes of no activity, the system must reduce speed, and after 5 minutes, it should stop or go into standby mode. These systems must use IE2 or higher efficiency motors, VFD, and sensors to detect passengers. Section 8.9 Elevators Motor Drive Positions Provision. This section requires elevators to use energy efficient motor drive systems, and the motor drive must be properly sized based on the elevator's capacity and usage, ensuring efficient operation while minimizing uh, energy loss. Section 8.10 High Capacity Elevators and Escalators. For high capacity elevator and escalator systems, the use of line regenerative drives is required. These drives allow energy generated during braking to be recovered and reused, improving overall energy efficiency and reducing electrical consumption. Section 8.11 Elevator lighting requirements. Elevator cars must be equipped with energy efficient lighting. Energy efficient lighting must be provided to ensure passenger safety during power interruptions while still complying with energy efficiency standards. Section 8.12 Elevators operation requirements. Elevator system must operate using energy saving modes. Automatic controls should minimize idle time and reduce unnecessary power use, especially during periods of low demands. Section 8 Construction Documentation. For occupancy permit approval, several construction demands are required. These include inspection reports for motors, VFD pumps, and soft starters, energy level verification, and as-built plans, especially for Section 8.7 as-built rooftop water tank drawings and inspection reports must be submitted. And then continue to Section 9 electric power distribution. Uh, Section 9 covers the building's electrical power and distribution system. This includes transformers, power factor corrections, cable sizing, surge protection, UPS, generators, EV charging system, and proper ventilation of electrical rooms to ensure safe and efficient operation. Section 9 Construction Documentation. Construction documentation for Section 9 includes as-built electrical plans, testing and inspection reports, nameplate photo documentation, and thermal scanning reports. This confirms that the installed system match approved plans and meets safety and efficient requirements. Section 10 Renewable Energy System. This section focuses on renewable energy systems such as photovoltaic system, solar water heaters, and solar cooling systems. These systems contribute to reducing the building's dependence on conventional energy source and support sustainability goals. Section 10 Construction Documentation for renewable energy and required document include as-built plans, ocular inspection and verification report, and when applicable, a Green Energy Option Program or GEOP contract. So, therefore, from Section 8.7 to 10, it ensures that buildings are designed and constructed with energy efficiency, safety, sustainability in mind, proper system design, and complete construction document that are essential for compliance and for security and occupancy permit. Thank you.